Welcome to the Manga Bay Newscast. It's June 15th, 2022, and I'm your host, Mike Gurecki, bringing you the news and inspiration from nature's front line. Today we're looking at two stories that show how bioacoustic research is helping us better understand the lives of marine mammals, and we take a listen to some of the recordings informing that research. Our first guest is Erin Ross-Marsh, the lead researcher behind a study of humpback whales at the Vema Seamount in the South Atlantic Ocean off the coast of South Africa. Ross-Marsh tells us about the study's finding that these humpbacks were making gunshot calls, a type of non-song call that was previously unknown in these particular whales. And she plays some humpback songs, some non-song vocalizations, and some gunshot calls for us to listen to. We also speak today with Sarah Trabue, a research assistant with the Wildlife Conservation Society's Ocean Giants program, who is the lead author of a recently published paper detailing the findings of a bioacoustic study of bottlenose dolphins in the New York, New Jersey harbor estuary. Trabue tells us what the study reveals about dolphin behavior in the highly trafficked waters of New York Harbor, and plays for us some of the dolphin vocalizations recorded as part of the study.
We basically knew that dolphins were present around this area from spring to fall, but this is verifying that in a formalized way. And it's also showing that when they're here, they're spending the majority of their days feeding. So that suggests that the New York Harbor might actually be a foraging ground for this migratory population, and that may be one of the influencing factors for why they're actually coming up to this northernmost part of their range.
Erin Ross-Marsh is a PhD candidate at South Africa's Stellenbosch University, who also works with an organization called Sea Search Research and Conservation in Cape Town. The recordings that inform the study she led, which we'll link to in the show notes, were made during an expedition led by Greenpeace International and Sea Search Research and Conservation. The goal was to learn more about two populations of humpback whales that are known to migrate through the Vema Seamount, a biodiversity hotspot that lies about 1,000 kilometers or 620 miles off the coast of Cape Town in the South Atlantic. Scientists think the humpbacks use Vema as a foraging ground as well as a navigational waypoint on their way down to Antarctic waters. The hydrophones Ross-Marsh and team lowered into the water from the Greenpeace ship Arctic Sunrise picked up humpbacks singing songs and making some familiar non-song calls, but they also recorded the whales making calls the researchers were not expecting to hear. Here's Erin Ross-Marsh with more about the impetus for the study and what the research team found.
The idea for the original research cruise was that the Greenpeace team was out looking for ghost gear. So the Vema Seamount is an incredibly diverse and productive area. So lots of fish, lots of lobsters and things like that. Because of the way that it is structured, it has an ecosystem very similar to more sort of inshore habitats. And because of that, in the past, it was quite heavily fished. And obviously, a lot of the times when an area is heavily fished, a lot of ghost gear is left behind. That continues, obviously, to pollute the area and also to continue to fish and removes animals from the environment. So that was the sort of the logic behind the cruise initially. But obviously from our perspective, we really were interested in trying to get acoustic recordings of the Southeast Atlantic, which is not an area that we survey very often. So for us, it was a really good opportunity to try and get some recordings from outside, in that area. So we had towing hydrophones, which were attached to the back of the boat or the ship, and I think it's called the Arctic Sunrise. And so those were collecting data from the entire cruise and more sort of general things. But when we got to Vema, my colleague Jack Ferry, he helped deploy the two hydrophones that we used to record the soundscape at Vema itself. So our initial sort of idea was that we wanted to gather song data from the humpback whales that would come past, or whether or not there are humpback whales there, or what kind of species we can sort of hear in that area, because obviously, like I said, it's not a very well surveyed area. Because of its position near the Dolphins ridge, which is kind of where humpback whales sort of migrate along, we thought that, the whales would sort of migrate past there. And we know from previous studies and from our own work that migration is also a time where they would be singing. And so our initial sort of idea was that we would get song information or something like that. Ironically, we didn't get any song, but we did hear the whales, which was still very cool. So yeah, I think that was the sort of reason behind it.
We do have a humpback song to listen to today, though it's not from this particular study, as you've just said. You didn't record any songs on that expedition, but what did you record?
What we discovered was actually more sort of non-song data. So humpback whale vocalizations are divided into song and non-song, and these are used they're for different functions. So song is traditionally thought to be quite important in terms of mating behavior. So as far as we know, males are the only ones that sing. And this has some function for breeding. So they think that it's sort of like a licking sort of system where a male will establish a territory and he will sing his song, which has functions for both attracting females and repelling any sort of like rivals in the area. But there are other sort of functions that we're not entirely sure of. So you can't entirely say that it's a breeding behavior. And song is very structured. It's very hierarchical. You have the units, which are the smallest sound to our ears. Then you have multiple units create a phrase, repeated phrases create a theme, and multiple themes then create a song or a song cycle. And that's sort of how we recognize what song is. On the other hand, you have non-song, which is very unstructured, more short sounds that are used in sort of interaction sort of situations. So mother and calves will use non-song. You'll hear non-song in sort of situations where there are escorts in a group. And in feeding. So you'll hear these kinds of sounds in those sort of situations, not necessarily song. And so, from our perspective, we were expecting quite a lot of song, but actually didn't get almost any at all. The song that we did get and that we did hear was like 30 seconds and very poor quality. And so we obviously realized, no, that's not going to, that can't be a basis of a paper and it's not really a basis for a study. But there was a lot of like non-song calls, which was quite interesting to us, yeah.
And of course, you supplied us with some examples of these calls to listen to, but maybe first we could listen to the humpback song you did send. Can you tell us where this recording is from and what we're going to hear?
So the song that you're going to be listening to is from a place in Cape Town called Kommetjie, only a couple of kilometers offshore, off the shore. And this was recorded in 2018 during the southward migration. So when the animals are coming back from their breeding grounds. And so what you're listening for here is a repetition of sounds and a very clear, distinct patterned sort of sound. 30 seconds, you may not hear sort of like the themes and the phrases as such, but song is very typical in that it's often very distinct, very clear sounds that are made, whereas non-song is not sort of that way.
Okay, here's that humpback song. And we also have a few recordings of whoop calls. I assume that's one of the non-song calls you were talking about.
Yeah, it's a non-song call, and it's actually used quite often in interaction sort of scenarios within the humpback whale population. And you'll often hear them when they feed or when they're interacting with other members of the population. But because humpback whales are the way that they are and they don't like to go by the book, you also hear whoops in song. So they're either or. It just depends on how structured the vocalization is in terms of whether or not they're included in the song or whether it's just humpback whales chatting around.
Okay, here's a whole bunch of whoop calls in quick succession. And lastly, we have the gunshot calls, which our listeners might be somewhat familiar with because back in 2019, we featured on this podcast the first ever recordings of right whales breaking into song, which consisted of gunshot calls. So not the most musical to human ears, perhaps, but it is a very similar call to what you've recorded these humpbacks doing. Is this the first time anyone has ever documented humpbacks making gunshot calls?
It's the first time that we sort of know of that they've been heard and reported on in our area from our population. So we've heard them before off the coast of South Africa during sort of a surface active group. So breaching and interacting with one another quite actively. And so it's the first time that sort of we've been able to sort of report that in a proper scientific way. And a lot of people would be able to say, well, how can you tell that it's actually a humpback and not a right whale? When Jack was on the boat, so Jack Ferry, my colleague, was actually present on the boat during the expedition. And so part of his job was to sit on the bridge or at the bow and do marine mammal observations. So looking out for whales, dolphins, anything that he could see, making notes of them and saying watch encounters and how many of the animals you see, those kinds of sighting sort of records. And then once we gone through the actual recordings, we noticed these impulsive sounds or these gunshot sounds, which is a very typical right whale sound, as you said, and as your listeners will probably be familiar with. But we heard no other right whale vocalization. So one of the reasons why we think that it's very, very likely to be humpback whales is that there were no other right whale sounds and no right whales were seen in the area. But on top of that, these sounds were made in between very typical, very acknowledged and, known humpback whale sounds. So it would be like a whoop or a grumble and then an impulsive sound and then another whoop. So in between these sounds that we know, with very high confidence that they are made by humpback whales with these impulsive sounds, which was really strong evidence towards the fact that they were being made by the animals. On top of that, we spoke to colleagues that have worked in the area in the past about this sound because, obviously we want to make sure that we're not putting something out there that could be refuted or could be mistaken or could be, proved to be wrong in the future. And we'd spoken to colleagues and they also mentioned that they had seen it in their populations as well. So we were pretty confident. As well as in the paper, we reference a paper by Rekdal, I think it was in 2015, and they have a similar sound called the bop. So it's not really a sound that is entirely new to science, but it is something that's super unique that we found in this specific area, and we actually haven't reported on it before from our population specifically. When you hear the word gunshot, you're probably thinking that it's going to be quite a, gunshot adjacent, but they really are incredibly similar to a gunshot in that they're actually, in most of the cases, when you have a really clear example, you hear that crackle that a gunshot would actually have. You also hear a little bit of reverberation at the back of it, which is just a sort of characteristic of the sound. So yeah, they're a very interesting sound. And to me, I'm not a physiologist at all, but I think that it would be very interesting to know how they make those sounds. But yeah, it's a very, very unique sound, and we were quite excited to see it.
Great. Here are a few gunshot calls back to back. Now, are there any theories or speculation as to why humpbacks would be making these gunshot calls?
I suppose in this scenario, it might be too early to say because, as I said, the area is not really well surveyed and we haven't heard, these sounds aren't very common. And when we do hear them, they're only in specific sort of types of scenarios. So we know that in right whales, gunshots are thought to be quite aggressive and probably indicative of animal size. So a larger animal would use the sounds to sort of indicate that, hey, I'm big, I'm bigger than you, I'm stronger than you, etc., etc. And so they're usually used when entering a mating group as a way to say, like, hey, look at me, listen to me, this is who I am. However, we don't yet know how it works kind of in humpback whales. They seem to be used in like social contexts and in feeding context, but it could similarly be used for aggression or something similar to how the right whale uses them. The thing is that we just don't know. We don't have enough information right now to sort of say, yes, it's this thing, no, it's not that thing. But I mean, that's the beauty of doing these kinds of research surveys, because you find all of these incredible new things, and it opens up a whole lot of other questions that we now need to ask to be able to answer that first question.
In fact, to that same point, you spoke with Manga Bay staff writer Elizabeth Clare Alberts for an article she wrote about this same study, and you're quoted as saying, "We've been studying humpback whale vocal communication since the early 70s, and even after decades of study, we're still discovering completely new and unexpected things." How remarkable is it to still be discovering new things about a species we've been studying for decades?
Yeah, so I mean, when you think of the first sort of report of humpback whale sounds and song, because song has obviously a lot of attention, just because it's so complex and so beautiful to our ears, and it almost has like a magical quality. So from 1971, when that first like seminal paper came out, a lot of scientists now had a fascination with the sounds that these animals make. And, the 70s was a while back. And there's still more things that we're learning about, and even differences in the hemisphere. So how northern hemisphere whales vocalize and how they interact with one another versus versus what we see here in the southern hemisphere is also completely different. And, we're seeing things that are completely, they throw the textbook out of the water. And yeah, it's just an incredible sort of field to be in, because these animals are not sort of meeting our expectations, which is something so wonderful and exciting, because after so many years of study, and we're focusing on these kinds of things in our studies, and now we have so many more amazing and in-depth techniques to study these animals. We have better recording equipment. We have better statistical analyses to use. We're still discovering all of these different things. Take, for instance, the idea of song. We still don't know with 100% confidence what it's used for. It's been studied since the 70s. And we still can't say, okay, 100% this is its function, because it's heard in places where, according to our original sort of ideas, it shouldn't be heard there. So I think it's a really exciting field to be in. It's really, you never know what you're going to get thrown next. And these animals are always throwing curveballs and things like that. And, I'm working currently with an expert in song from the sort of Australian populations, and how Australia even differs from South Africa is like, it's almost like worlds apart. And just knowing that these animals, no matter where they're from and things like that, there's always something new to learn. You can never know everything about a species, which is just a very exciting thing.
So back in 2019, we featured on this podcast a marine biologist named Jim Darling, who played for us humpback songs from 4 different breeding grounds around the world. And the songs were all remarkably similar, like nearly identical. So the theory is that they are somehow learning these songs from each other, despite being from distinct populations who we didn't really know had that much interaction with each other. Is there any chance that your humpbacks have learned the gunshot calls from other humpbacks, or possibly even from right whales?
Well, I mean, that's a very interesting question. My initial response is I have no idea. I mean, these animals are capable of learning in, ways we're just sort of getting to know. You mentioned Jim Darling, and I read a recent paper that in the same year or in the same season, you had animals that were seen in like a Mexico breeding site, and then a few months later they were in Hawaii. also breeding there. So these animals travel massive distances, and that's kind of how we envision them to like learn their songs. Exactly what Jim was saying in the previous podcast. We also have sort of evidence of in other cetaceans where dolphins are learning calls from porpoises. There was a recent paper that came out where there was a lone dolphin that has now learned how to vocalize in the very same way as, or a very similar way as a part of porpoises that in the area where it lives in its range. So if a dolphin can learn how to speak porpoise, maybe it's not technically out of the realm of possibility that a humpback whale can learn, you know, some things from other individuals, like the right whale, learning these calls. It could also be something that is just, you know, innate within the creature that we're only just discovering and just learning now. I mean, these animals were they were whaled into very, very low numbers. And we're seeing trends and patterns now that we've never seen before. But, you know, part of that and thinking it to ourselves like, oh, they're doing new things and they're doing and they're going to new places. You can't really say like, is it new or is it just something that we're noticing now because the populations are recovering? So it could be something like that now that we have access to more animals and we're able to listen to them in more effective ways with the newer equipment and better listening devices and things like that we're discovering these things because of being more dedicated about that kind of thing. So yeah, my initial answer is I don't know, but that is also something that, you know, it opens up those questions about like, did they learn this from another population? Did they learn this from another species? Or is it just something that we've never really noticed before because we haven't really had access to this specific population's recordings or this specific area's recordings or things like that?
You mentioned earlier that the Vema Seamount is a diverse and productive area, but there's also still some fishing and ship traffic in the area, as well as the ghost gear you mentioned earlier, which of course is a problem. Could your research help in designing conservation measures for the Vema Seamount?
Well, I mean, that's the dream of every scientist, right? To be able to use their research to help their study species. So in 2007, fishing was banned in that area. But yeah, I mean, you can't really say like nobody fishes there or that there's no longer any sort of traffic or whatever. But the whole idea that this area might be important for humpback whales as they're migrating to their feeding grounds becomes quite an important question. So seamounts are, for a lot of different species, seamounts are important for opportunistic feeding, opportunistic rest, maybe even a point of aggregation where they could breed or interact with other members of their species. Or it's a navigational checkpoint that makes them know, like, okay, I'm on the right track. You know, like I need to go to this place and this is sort of my landmark to get there. So knowing that we have quite a lot of non-song in this area indicates that there is, you know, like activity by these animals in this area. When Jack was on the ship, he saw, and we mentioned it in the paper, he saw two humpbacks engaging in what is very likely feeding activity. So long dives, very active on the surface, blows and tails and all of those kinds of things. And so we know from that, or it's very, very likely that in this area they're feeding. And so for us, that's a pretty important thing to know. This area is very, like I said, undersurveyed. And so for us to know that Vema is an important ground for feeding or for rest for these animals has implications into we need to protect this area because maybe this is how they get from point A to point B. Maybe this is an incredibly important spot. And if it's overfished or if it's destroyed in some manner or some form, that it may have implications for whale recovery. And our humpback whales in this area and sort of the population that we assume that it is, or that it's a part of the animals that come past, that population is doing quite well. It's recovered really, really well. But whether but do we know whether Vema was instrumental in that recovery? Maybe not. I think that there are like important implications in terms of like knowing that this is a place where animals could find or improve their survival, improve their fitness. And I think that it's important for us to obviously know more about the area, but this just gives a snapshot for us to say like, maybe this area, we need to pay more attention to it, or we need to sort of, look into protecting it because there are implications that it is an important space for these animals.
Now we turn to our second story of how bioacoustics are helping us learn more about marine mammal behavior. Bottlenose dolphins have been spotted in and around New York Harbor with increasing frequency in recent years. So a team of researchers at the Wildlife Conservation Society set up hydrophones off the coasts of Brooklyn, Queens, Staten Island, and New Jersey to study what's bringing all these new tourists to the Big Apple and to better understand the threats to the dolphin's survival in these heavily trafficked waters. Sarah Trabue is the researcher with the Wildlife Conservation Society's Ocean Giants program who led the study.
So this project started before I came on to the Ocean Giants team. Howard Rosenbaum and Mindy Reckdahl of the Ocean Giants program got a grant from the Hudson River Foundation to put down these underwater microphones throughout New York Harbor in order to look at the soundscape of the underwater environment there. So, quantifying sound levels, how noisy is that environment, considering all the shipping activity that takes place there, and also trying to get a sense of what species you can detect there, species that vocalize. So through the acoustics, what kind of species are present versus not present, and when they're present, and where throughout the harbor you're detecting them. So that was what the grant was given for, was kind of this classification of underwater noise levels, and also looking at a broader scale what species are present. And the focus oftentimes in this area has been on these larger baleen whale species. So there's humpback whales, there's fin whales, there's North Atlantic right whales, which are of course critically endangered and a huge point of interest. And this work is part of a broader umbrella of work that's currently being done to look at marine mammal presence in the waters, both really inshore in the New York Harbor, but also all the way out into the offshore wind lease areas that are going to be under development. So that was kind of the start of the project, and that happened all before I came on. But in 2018, I moved to the city, and I joined the Ocean Giants program as a volunteer. And in my capacity as a volunteer, I was doing a manual review of the acoustic files that they were getting off of these underwater microphones. And so that was looking through basically pictures of sound, which they're called spectrograms. And we were looking at these pictures of sound, and just based on these pictures, you can see and then you can also hear if there are, fish species, dolphins, different marine mammal species. And so when I was going through this manual review of these spectrograms, we were getting a lot of dolphin activity on these underwater microphones. And so at about that same time, I was looking at the literature and I was reading about how you can hear whether dolphins are foraging based on acoustics alone, using this sound that we use in our study called a foraging buzz. And this foraging buzz is basically when dolphins are echolocating and they're approaching their prey item, they produce clicks at a faster and faster rate so that they can get a better and better, higher resolution image of the prey in space and time. And it makes sense, right? As they approach the prey item, they'd want to have a better idea of where it is in space and time so they can have a higher chance of success when they're actually trying to grab it and consume that prey. It was just kind of this, I feel like I came on at a very convenient time. I was very lucky that they brought me on. And then as I was going through this manual review for data that had already started to be collected, I was also reading about these foraging buzzes in the literature that you can use to understand dolphin foraging activity. And so that's kind of how this aspect of the acoustic monitoring in the New York Harbor came to fruition.
So what are the main findings or takeaways from your study?
The population of dolphins that are found off the coast of New York and New Jersey belong to a migratory stock. So there's, been in a previous assessments where they found that these bottlenose dolphins are migrating to this northernmost part of their range, which is around off the coast of New Jersey. But they're in the New York Harbor and around the New York Harbor, there hasn't really been formalized assessments of when they're here, what they're doing here. So one aspect of this is that it's really exciting. This is one of the first times that in a formal capacity, we're saying, okay, dolphins are here, they're detected here acoustically from this time to this time. And here are some of the environmental variables that are associated with their feeding behavior, which is, feeding is a critical life function. So it's a particularly important, to know when they're feeding in order to better, take better actions to conserve them. So our overall findings, so we basically knew that dolphins were present around this area from spring to fall, but this is verifying that in a formalized way. And it's also showing that when they're here, they're spending the majority of their days feeding. So that suggests that the New York Harbor might actually be a foraging ground for this migratory population, and that may be one of the influencing factors for why they're actually coming up to this northernmost part of their range. They might be following the food.
All right, and we have some recordings from the study to listen to today. There's one that is called Bottlenose Dolphin Clicks and Whistles. What are we going to hear in this recording?
Yeah, so bottlenose dolphins produce a variety of sounds. So whistling, they produce, typically it's associated with social contexts, and many people are familiar with the idea of a signature whistle. But the basic premise is dolphins produce a particular whistle that has a contour that's associated with a particular individual. But they also produce whistles in other contexts as well. But here in this study, we didn't study whistles. Instead, we studied a broadband sound that are echolocation clicks. So dolphins produce echolocation clicks when they're navigating their environment and foraging. And they can also produce clicks in social contexts as well. But the basic premise behind these echolocation clicks is, just for some background in case people don't know, so dolphins produce echolocation clicks, and the premise there is that they produce a click. That click travels through the water, it hits an object, and it echoes back, and the dolphin perceives that echo. And so they can use information about the timing of that echo in order to create an image of the world around them, create a spatial awareness of what's going on around them through the echo of that sound alone. So you can imagine that when they're just navigating their environment, they produce clicks, every so often just to get a basic idea. So you have a click, a click, a click. And then if they produce a click and they, there's a sense that there's a prey item, then as they approach that prey item, they start to produce clicks a little bit faster so that they can get the echo of that click and have a better sense of where that fish is in the water. And then when they get really close and the clicks get really, really close together, it starts to sound to our ear like a buzz. And so that's where the term foraging buzz comes from. It's actually echolocation clicks that are produced in very rapid succession with a very short duration between the clicks. And so we can look at the time between the clicks. It's called the interclick interval. And when it's short enough, that's what we can use to infer that a foraging buzz is being produced. And from there, we can infer that feeding activity is taking place. And so what you hear in some of these audio files, you'll hear both those whistles, but you'll also hear some clicks. And sometimes if those clicks, you'll hear click, click, click. But when they get really close together, it'll sound like a buzz. And that's the foraging buzz.
Okay, here's the bottlenose dolphin clicks and whistles. And here's a couple recordings of the foraging buzz, which I'll just play back to back. You mentioned earlier that these recordings might show that the dolphins are following their food here into New York Harbor. Does that help explain the increased presence of dolphins in recent years?
There's definitely some hypotheses. There has been a recent recovery of what are called bunker, but the official name is Atlantic menhaden. It's a small oily fish that are an important prey item for a lot of marine mammals. And no formalized studies have been done here to see, if, for example, if you look at the stomach contents of a bottlenose dolphin, if there's a lot of bunker in their stomach. But one of the running hypotheses is that this recovery of Atlantic menhaden or bunker has been a huge draw for not just bottlenose dolphins, but also the larger whales that we're seeing increasing in abundance over the past decade or so. Other hypotheses include, there's the habitat here has been improved due to things like the Clean Water Act or various policies that have made it have improved the quality of the water here and the quality of the environment here and made it more suitable for use by marine mammals. Another possible, influence on bottlenose dolphins coming to this area more is if temperatures of the water are getting warmer due to climate change. There's a lot of, this study answered a lot of questions, but it also left a lot of questions. And so it's a great jumping off point for further studies about looking into, possible drivers of these kind of patterns that we are observing.
What for you are the most interesting or pressing questions that still need to be answered?
We did our analysis at 2 different scales. So we looked at trends in foraging activity and how they related to environmental variables over longer time scales, so across the weeks and over the seasons. But we also looked at foraging patterns throughout the day. And these trends throughout the day were not very well explained by the environmental variables that we chose here. So that suggests that maybe there's other factors that are influencing foraging behavior on these smaller temporal scales throughout the day, and that warrants further study. And I think it would be great to look at kind of the human dimensions of, this estuary and how those kind of human dimensions may be influencing foraging patterns. So, for example, looking at vessel noise and vessel presence, things like this, to see if, maybe, this is all speculative. This is, I think, great fodder for further research. But whether or not dolphins are foraging less during times where there's a lot of people out and about on the water, because it's a great question about what is driving these dolphins to come into these areas when there is so much human activity. It is a very highly urbanized environment. So looking at how they might be interacting with the human activities in this area is also a huge point for further research. And also, complementing this inshore data with with data from further offshore or other points along their migratory range. So, for example, you could do similar studies in other parts where they are in different times of year. So you could see. So we found in the New York Harbor that foraging was increased when the water temperature was above about 18 degrees Celsius, so about 64 degrees Fahrenheit, and in the late summer and autumn. So we could look at other points along their range. So they spend the cold water months off the coast of North Carolina, and then they migrate northwards during the summer. So you could see, in areas like North Carolina, does foraging still seem to be higher when the water temperature is above 18 degrees Celsius or 64 degrees Fahrenheit? So that would give you, an idea of, is there something about the water temperature that is more conducive to foraging? So you could see if different points along their migratory route, if sea surface temperature that is associated with increased foraging was stable across their migratory range. You could also look at, what are they actually eating here and do a formalized study on that. For example, looking at diet composition. There's about 1 million different ways you can go with this. But also there are these offshore wind developments that are happening in the Northeast. And so understanding how dolphins are interacting with things like vessel presence and vessel noise, which will likely increase in order to support these offshore wind development activities, is also, it's another worthy route for further investigation.
Are there any ways in which the findings of the present study might help design any conservation measures for these dolphins out here in New York Harbor, which of course has a lot of human activity going on?
What I've been telling people is, the more that we know, the more that we can do to minimize risk and harm to these animals and live alongside them. So I would say this study contributes baseline ecological knowledge about a population that we knew very little about. And so in terms of conservation efforts, I'd say this is providing a wealth of information that we previously didn't have. It also puts bottlenose dolphins into people's minds as many New Yorkers and people around the world don't know that there's this abundance of marine wildlife that are here right off the coast of New York. And so in terms of, the actual research, it provides a baseline of ecological knowledge that can be used to inform policy. But it also is contributing to people's awareness of this marine life that's right here off the coast in their backyard. You and I are in Brooklyn right now, and we're not very far from where dolphins are probably feeding right as we speak. So I think that that's also, both having the knowledge and is huge, and the awareness is huge for, promoting conservation actions.
Did you have any noteworthy findings around the dolphins' feeding behavior in New York Harbor and how that might be influenced by all the human traffic in the area?
One interesting thing to note, going back to the vessel noise kind of part, looking at human dimensions. So in this study, we only looked at environmental variables. We didn't specifically study any kind of anthropogenic or human influences on foraging behavior of these dolphins. But one interesting finding that we had was in the upper bay, there was one recorder, one underwater microphone or one hydrophone that was located in the upper bay north of the Verrazano Bridge. And this recorder was in an area with very, very high levels of shipping traffic and vessel traffic. And on this recorder, we only had 3 days of dolphins' presence detected, and only 2 of those 3 days dolphins were foraging in. So we didn't formally study the relationships between, vessel activity and dolphin foraging behavior, and that's a great avenue for further research. But what we did find is this interesting pattern where in an area with a lot of vessel traffic, we had very, very rare dolphin detections. So I think that's an interesting thing of note.
Well, before we wrap up, would you care to say something about why bioacoustics are great for this kind of research?
This passive acoustic monitoring effort was really spearheaded by Dr. Mindy Reckdahl at the Ocean Giants program at Wildlife Conservation Society. And passive acoustic monitoring is a fantastic way to conduct research in very challenging and urbanized environments such as the New York Harbor, because it is very hard to get out there and see the dolphins, especially, it's not hard to see that. You can, sometimes you go out on the boat and you can see them, but it's a challenging environment to conduct research in because of all the human activity that's going on. And so passive acoustic monitoring allows us to investigate not only marine mammal presence, but also how they're using these waters, which is kind of a level beyond just this, baseline about presence, absence. Are they here? Are they not here? When are they here? And where are they here? But also how they're using these waters, using acoustics alone. And so that allows us to look at these behaviors over time scales and in areas that would be really, really challenging to do, if not impossible, without these methods, these passive acoustic monitoring methods. So it's my little shouts out to bioacoustics as the field of the future.
If you enjoy the Manga Bay Newscast, we ask that you please help spread the word by telling a friend. That's the best way to help expand our reach and keep the show growing. Another way to help is by becoming a monthly sponsor via our Patreon page at patreon.com/mangabay. We are a nonprofit news outlet, so just $1 or more per month would really help us with offsetting production costs and hosting fees. So if you're a fan of our audio reports from Nature's Frontline, please head to patreon.com/mangabay to learn more and support the Manga Bay Newscast. That's patreon.com/mangabay. You and your friend can join the listeners who've downloaded the Manga Bay Newscast nearly 500,000 times by subscribing to this podcast wherever you get your podcasts from. Or you can download our app for Apple and Android devices. Just search either app store for the Manga Bay Newscast app to gain fingertip access to new shows and all of our previous episodes. And of course, you can read all of our news and inspiration from Nature's Frontline at mangabay.com. Or if you prefer to keep up with us on social media, follow us at facebook.com/mangabay or on Twitter and Instagram. Our handle is @mangabay on both those platforms. Thanks as always for listening to the Manga Bay Newscast. I'm your host, Mike Gurecki, signing off. Talk to you again in 2 weeks.